Hello everyone, welcome to Computer Network Lecture Series. I'm Shilpa, Assistant Professor. In this video, we will learn about what do you mean by logical address, physical address, and port address. Okay. So first we will see what do you mean by logical address. Okay. So logical address is also known as an IP address. So an IP address is a unique numerical identifier assigned to every device connected to a computer network. So that uses IP protocol, that is Internet Protocol for communication. Okay. So let us say take one example. In this example, there are lot of end devices are connected. This is one end device, here one end device, here one end device, and here also there are end devices are connected. And these end devices are connected to switch. It forms a local area network one, and that is located in New Delhi. And these three end device form connected to switch, and this forms another local area network. It is in Chennai. Okay, so these in turn connected to the routers. Okay, so here this computer wants to send data to this computer. Okay, so the third computer in a local area network one wants to send information to second computer in a local area network 2. Okay, it means the computer with the IP address, that is 172.15.150.4, wants to send, okay, it is going to send some data to 192.168.150.3. Okay, this is IP address, because every node in the computer network is identified with the help of this IP address only. Okay, now we will see more about this IP address. When I say IP address, okay, so there are two variations. One is IPv4 address and one is IPv6 address, and these are logical addresses. Okay, so why we are calling IP address is logic address means because it is assigned and location based, and it is changeable, and it is used for routing across the network. That's why we are calling this IP address is as a logical address. Okay, so if you consider this scenario, so if you consider previous scenario, okay, so if you take this LAN is located in New Delhi, and here this LAN is located in Chennai, right? Suppose if you take this computer, okay, and I place this computer in the LAN of Chennai, okay, I'll remove this computer and I place this computer in the LAN of Chennai. Okay, simply I can remove this IP address and I can assign the IP address in this range, because the location of the devices is changed. So here the local area network is ranging from 192.168.150.2, and it is assigned 3 and it is assigned 4. Okay, and the next device, the newcomer, is assigned with some other IP address that is within this network range, that is 192.168.150. I can assign either 5 or 6, anything. Okay, so 192.160 means 192 means based upon the class, it represent the class C address, and in the class C address first 3 denotes the network address and last one is the host address. Okay, so the host address may be ranging from 0 to 255. So in that 0 to 255, first one is network address and last one is the broadcast address. So remaining addresses we can accommodate any 254 hosts we can connect. Okay, so this is the IP address. So already you know IP address is a 32-bit range. It consisting of 4 octets, and this IPv4 address is either represented in dotted decimal number or dotted binary form. Okay, so each octet is consisting of 8 bits, means 8 into 4 octets. Okay, means total length of the IPv4 address is 32 bit, and each octet is ranging from 0 to 255. Okay, and these 4 octets are separated by dots. That's why we are representing 192.168.15.2 like that. Okay, and the length of, based upon the length of the IPv4 address is 32 bit. Okay, so 2 power 32 gives 4.3 billion unique IP addresses we can allocate. Okay, this is about IPv4 address. So next, same thing. This is the scenario how we are representing the IP addresses to the end systems. Okay, and these are separated with dot. This is 192.168.10.26. In this way, we are declaring the IP address. Next, we will see the IPv6 address. IPv6 is nothing but Internet Protocol version 6. Okay. So it is introduced by Internet Engineering Task Force in 1998. Okay. So IPv4 address is we can access 4.3 billion. Okay. But day by day the internet is going fast. So number of devices that wants to connect internet is going fast, right? So to resolve that IPv4 difficulties, IPv6 came into picture. Okay, IPv6 is also known as a Internet Protocol next generation. Okay, it is a 128 bit length and it consisting of 8 octets. So the range of this each octet is 00002 FFFF. So here four numbers that is separated by a colon. Okay, so this is the hexadecimal in IPv4 address is represented in hexadecimal format. So this hexadecimal, this consisting of 4 numbers. Okay, it is separated by colon. Okay, so in this 128 bit, so first 64 bits are denoted as a client ID, and next 16 bits are used for subnet ID, and next 48 bits are used for network part. Okay, and so here the length of this IPv4 6 is 128 bit. So 2 power 128 gives 340 trillion unique IP addresses we can allocate. Okay, so example for this IPv6 address is we can use IoT devices and we can access Google services, mobile networking, and cloud computing devices, etc. Okay, so next one. So please, can you identify appropriate, that is valid IP address and invalid IP address? First, let us see 23.25.12.56. So it has 4 octets and the octet range is 0 to 255. It is a valid IP address. Next, 12.3.234.256. So it consisting of 4 octets, but the last octet is 256, but the range is 0 to 255 only. So B is invalid IP address. Next, 3.2.4.2. So it is consisting of 4 octets and it is ranging from 0 to 255. It is a valid IP address. Next, 255.255.255.255. It is also a valid IP address because the range is 0 to 255 only, right? Next, 96.5.3.6.45. So here, see here, there are 5 octets present in this, okay? But IPv4 address is having only 4 octets. So it is an invalid IP address. Next, 16.2e.45.34, okay? So here 4 octets it is considered. But the second octet is 2e. It is represented in hexadecimal. But IPv4 address is represented in only either dotted decimal number or a dotted binary number. It is an invalid IP address. So A, C, D are the valid IP addresses and B, E, F are the invalid IP addresses. Next, we will see the physical address. Okay. So this physical address is also called as a MAC address. MAC is nothing but media access control. Okay. So every node in a local area network is identified with the help of MAC address only. Okay. So let's take an analogy. So if IP addresses are like the location of the person. Okay. And suppose if a person is in Delhi, his location is Delhi. If a person is in Mumbai, his location is Mumbai. If a person is in London, his location is London. So IP addresses are like location of the person. So wherever the person goes, his location gets changed. But MAC addresses are like name of the person. So wherever he goes, his location may change, but his name will not get changed. Okay, so that is the main difference between IP and MAC address. Okay, so in this example, we have many end devices and intermediate devices. Suppose this computer wants to send a message, okay, so some data to this computer, okay. So this communication happens with the help of IP address as well as MAC address, okay. So actually router needs IP address and switches needs MAC address in order to send data or to establish communication between the devices, okay. So for example, this is the source. It wants to send some data to the receiver of this destination. So the data it is going to send, it is going to add a IP address as and a MAC address. Okay, when the router receives this packet, it takes and the forwarding decision is based on the IP address, because the the router needs IP address. Okay, once the data is received by the switch, okay, once the data is received by the switch, so it is the responsibility of the switch to deliver the data packet to the right destination. Okay, right. So switch gives the data to the right destination based upon the MAC address. So IP addresses are router friendly addresses, whereas MAC addresses are switch friendly addresses. Okay, so the IP address or a logical address which we can change, but MAC address we cannot change, and it will be unique throughout the world. So if you have a computer and that computer's MAC address will not given to any computer in the world, at the same time MAC address cannot be changed. Okay, so see here, so the MAC address, every node in a local area network is identified with the help of MAC address. And one more thing, the MAC address is also known as a physical address or a hardware address. Okay, these are unique and cannot be changed. Already I told. Okay, and this MAC address is assigned by the manufacturer itself. Okay, and it is represented in hexadecimal format, and it consisting of 6 octets, and it is represented in hexadecimal format. The range is from 00 to FF. Each octet is 00 to FF. Okay, so in first octet it consisting of 8 bits, 8 into 6 octets. So 8 into 6 means 48 bits. So MAC address is 48 bits. Okay. Next, we will see the differences between IP addresses and MAC addresses. Okay. So both IP address and MAC addresses are used for communication purpose only. Okay. So coming to IP address, if IPv4 we are using means it is a 32-bit length, and if IPv6 is nothing but 128-bit length. So the MAC addresses are 48 bits. Okay, and the IP addresses are represented in decimal. Okay, IPv4 is represented either in dotted decimal and dotted binary also we can represent, but and IPv6 is represented in hexadecimal. Okay, the MAC address is hexadecimal only. Okay, and here router needs IP address to forward the data, whereas switch needs MAC address to transmit the data. Okay, so this is the example for the IP address. Okay, 10.32.23.9. Okay, whereas MAC address represented 45.56.DA.D3.32.67. This is the example. It consisting of 48 bit and it is represented in hexadecimal format. Okay. Next, we will see what do you mean by port address. Okay. First, we will see simple analogy. Okay. Suppose your friend wants to send a parcel. Okay. So she is in Canada. Let's assume you are in Mumbai. Okay, so we need complete address for this parcel to reach to you. Okay, in the complete address details, one part of address will be make the parcel reach the Mumbai. Okay, first it reach the Mumbai. So another part of address will be make the parcel to reach your apartment. Okay, suppose if you are in your apartment and the parcel has reached your apartment, and last part of the address will make the parcel to reach the your that is house, that is you are staying in, suppose 12th floor. Okay, finally the parcel has reached you. So in real communication, any device can identified with the help of IP address and MAC address. Okay, but in the computers there will be so many processes are running. So to which process the data has to reach, that is decided by the port address or port number. Okay, so see here, reaching our city is nothing but reaching our network, that is based upon the IP address. Okay, reaching our apartment is nothing but reaching the correct host. Okay, that is done by the MAC address. Reaching the right person, nothing but reaching the right process. Okay, that is based on the port address. Okay, or port number. Okay, so see here, in port address. Okay, so many processors are will be running. So data which are sent or received must reach the correct person. So every processor in a node is uniquely identified using the port numbers. Okay, so the port is nothing but communication endpoint. So here the port numbers may be fixed or dynamic port numbers, that is ranging from 0 to 65,535. Okay, there are some examples of fixed port numbers are 25 and 80. Okay, so simple example, see here. So this is a local area network. Okay, so which is having three nodes. This is a node 1, node 2, node 3. Okay, so this is in turn connected to a router. Okay, right, and this router is connected to internet. Okay, which is cloud here. So finally this is somehow connected to our web server. So the web server which I am taking here is a youtube.com. Okay, so say this node is the node in this LAN is okay, there is so many processes are running this node. Consider this node. Okay, so in this node so many processes are running. Okay, one is Internet Explorer, and which is accessing the gmail.com. Another is Firefox, Mozilla. Okay, or Explorer, so where Google page is opened, and media player is running in this computer, and another is Chrome, Google Chrome is opened, and you are accessing YouTube. Okay, so in this with this which is this computer. Okay, so YouTube is running in Google Chrome. Say from this computer, from this Google Chrome browser, there is a request that is sent to the youtube.com, and then that request is accepted by the YouTube, and this YouTube data is now giving the video data. Okay, so IP address will take the data up to this stage. After reaching the stage, MAC address will take this to up to this part. Okay, MAC address is correct host. It will reach to correct host based upon the MAC address. Okay, so reaching the right host is decided by the MAC address with the help of switch. So switch is working based upon the MAC address. Router is working based upon the IP address. Okay, so up to this part, correct host we reached, that is YouTube, whatever video you want. Okay, so but if you observe in this computer, there are so many processes are running. Okay, Internet Explorer, Firefox, Media Player, and Google Chrome. Okay, so reaching the right process, that is Google Chrome here, is done by with the help of port numbers. Okay, so see here, so So this is this port number is some 46,567. This port number is something. This port number is something, and finally the Google Chrome port number is 64,323. Okay, when this processor is sending the data to the internet, the computer puts source port number and destination port number. So whenever it matches this destination port number, it gives the video data in Google Chrome browser. Okay. So with the help of port number, it is done. Okay. So this is about the logical address and physical address. Next, port address.